In this video, we're going to determine the maximum area of a rectangle that can fit inside a given ellipse. An informal description of an ellipse is an oval-shaped figure, and for our purposes, they will always be centered around the origin in this course. Okay? So to properly sketch the curve, let's determine the x and y intercepts of the ellipse that we're given. So this is the equation of our ellipse. If we let y equal 0, then what we get is 4x squared equals 100. In other words, x squared is 25, so x is plus or minus 5. What that means is this oval, it's not exactly an oval, but this oval that we're going to draw will have x-intercepts of plus or minus 5. Now, the y-intercepts will be determined by letting x equal 0, and we'll be able to say that 4 times 0 squared plus 25y squared is 100, ultimately leading us to y being plus or minus 2. So we can draw a fairly decent ellipse. And again, it's not exactly an oval, but that idea will suffice for our purposes. Now what we're trying to do is fit a rectangle in there, and we're trying to maximize the area of that rectangle. Okay? Now we need to establish an equation, and we need something to solve. So what we're going to do is we're going to find a point of intersection between the rectangle and the ellipse. So there are four possibilities. 4 points of intersection between the rectangle and the ellipse. Well, if we choose this point as our point of intersection, we'll have a negative x value. If we choose that point, we'll have a negative x and a negative y. And if we choose that point, we'll have a negative y. So let's choose this point. We'll know that x and y are both positive if we do that. Okay? So we're going to let x and y be represented by that green point. And when we do that, we see just the very simplest idea of when you first learn to graph, that green distance is x. And it's a positive value because we chose xy to be a point where both x and y are positive. So that green distance on your screen is x. Well, this distance here is also x. Now you might be tempted to say, but x is negative on the other side. What I want you to do right now is just recall that we specifically chose the point so we knew x to be a positive number. Using our fundamental ideas of graphing from grade 8, that horizontal distance of that green line is x, a positive value. So the horizontal distance of this equally long red line is also x, meaning the horizontal distance of the top of that rectangle is 2x. Okay? Now similarly, the vertical distance shown there is y, and by the same type of thinking, that overall vertical distance is 2y. Again, remember, we know y to be a positive number. So the height is 2y. So we've got a rectangle where length and width are given by 2x and 2y. And so we can say that the area of that rectangle is 2x times 2y, or in other words, 4xy. Okay, now saying the area of the rectangle equals 4xy is a pretty good start, but we only want one independent variable. So we're going to have to state x in terms of y or y in terms of x. Well, fortunately for us, we have this equation right here. And it's going to be pretty easy for us to do either. So in this video, we'll state y in terms of x. We'll see that 25y squared is simply equal to 100 minus 4x squared. And that when we divide left and right both by 25, we get this expression. And then we can take the square root and say y is equal to this expression. So we're going to show that work on the next couple of slides. And we won't have to worry about y being positive or negative because we know, again, y has to be positive because we specifically chose it to be a point in the first quadrant. So showing that same work here, we see that y is equal to the square root of 100 minus 4x squared all over 25. And again, as we mentioned, we don't say y is plus or minus because we know y to be positive. And a mistake sometimes people make is they'll say, okay, well, the square root of 100 is 10, the square root of 4x squared is 2x, the square root of 25 is 5, and they'll just replace this big expression under the square root with 10 minus 2x over 5. That's unfortunately not the case. It's not that simple. Okay, so we're left with this expression here that area as a function of x equals 4x times the square root of 100 minus 4x squared all over 25. Now, we'd like to know what the domain for x is. And we see here that x, the point xy, is somewhere along the outside of this ellipse right here. And so that means that x is going to be a number somewhere in between 0 and 5. Now, we can also say that we could say 0 less than x less than 5, or 0 less than or equal to x less than or equal to 5, depending on your interpretation of it. And so what we're going to do now is with our equation for area and our domain shown, we're going to determine the derivative and set it equal to 0. So let's use the product rule. The derivative of the first is 4 times the second function, we leave it alone, plus the first function, which is 4x, times the derivative of the second function. So what we'll do is we'll move that 1/2. We'll move that 1/2 in front and reduce the exponent by 1 to make it negative 1/2. And then we've got this negative 4/25 x squared. The derivative of that is negative 8 over 25x. Okay? And so we can say 8 prime of x is equal to, after simplifying a little bit, multiplying that negative 8 over 25x times 4x times 1/2, we get negative 16 over 25x squared, and we get that expression right there. Okay? Now we're going to set that whole expression equal to 0. So 0 is going to be equal to that expression. And we're going to multiply both sides by this square rooted quantity. When we multiply 0 by that square rooted quantity, it'll stay 0. When we multiply this expression by this quantity right here, I said square rooted quantity, meaning quantity to the 1/2. When we multiply that circled expression right here by this other circled expression, we're going to get 4 times 100 minus 4x squared over 25. And then when we multiply this expression by this, the exponents of negative 1/2 and positive 1/2 will be added to give us 0, and it'll become 1. So multiplying both sides, as it's shown at this bottom line here, multiplying both sides by that quantity will get us to where we want to go. So here it is shown for you. This is what you get when you multiply 0 by that quantity. This is what you get when you multiply that first quantity on the right-hand side by the quantity indicated on the last slide. And when you multiply this quantity by that, you simply get 16 over 25x squared. And the work is shown for you on the bottom. So our equation has actually now been simplified to this. 0 is equal to 4 times 100 minus 4x squared over 25 minus 16/25 x squared. Doing a little bit of distribution, we get 0 is equal to 400 minus 16x squared all over 25 minus 16/25 x squared. We can break apart this fraction as shown here. And when we do that, it's a little bit easier to collect up our like terms. We can say 0 is equal to 400 over 25 minus 32/25 x squared. So in other words, 32/25 x squared equals 400 over 25. Okay, just Kind of bringing that over to the other side if you like to say it that way. So 32 over 25x squared equals 400 over 25. Multiplying both sides by 25 gets us here. So x squared is equal to 400 over 32, which is equal to 25 over 2. That means x is equal to plus or minus the square root of 25 over 2, but we stated a while ago that we knew x to be a positive number because of where it is on there. So we can say that x has to be only positive 5 over the square root of 2. And then we can multiply top and bottom both by the square root of 2, and that gets us 5 root 2 over 2. So we're going to consider x equaling 5 root 2 over 2. That is, in fact, a number in our domain that we stated earlier of 0 less than x less than 5. And so we can sub in all of our values. If we let x be 0 or 5, the end values of our domain, we get an area of the rectangle of 0. But if we let x be 5 root 2 over 2 and sub that in, it works out a little bit more interestingly. We get 4 times 5, which is 20, root 2 over 2. That's the same as 10 root 2. And then if we have 5 root 2 over 2 times 5 root 2 over 2, we get 25 root 4 over 4. And that's 25 root 4 over 4 is the same as 25 times 2 over 4. And what we end up with there when we're multiplying that by 4, that ends up being, this ends up being a 50. And so we have 50 over 25 to the exponent 1/2. So this is 10 root 2. And then 50 over 25 is the same as 2, so it's 10 root 2 times 2 to the 1/2, which is 10 root 2, which is 20. So the maximum possible area of that rectangle is 20 square units.